Hi Debs! In this chapter, I will explain how DDD and Clean Architecture work together in the CV chatbot. The goal is to avoid a messy AI demo where the controller does everything. DDD gives us the language and concepts of the problem, while Clean Architecture gives us the structure and dependency rules. Together, they help us build a maintainable .NET API. This slide sets the objective. The course problem is not only called an AI model. We want a chatbot that answers questions about a CV while keeping the domain independent from technical details such as OLAMA, PostgreSQL, pgvector, or PDF parsing. DDD helps us name the concepts, and Clean Architecture tells us where each responsibility should live. Here, I explain what DDD contributes. It's not about creating unnecessary complexity. It's about making the problem explicit. We can identify a resume domain, a chat domain, and a search context. This gives us vocabulary for classes and rules. For example, a question cannot be empty. A chunk belongs to a document, and the chatbot should not answer if there is no evidence in the retrieved context. This slide explains Clean Architecture visually. The API is the outer entry point. Application contains the use cases and interfaces. Domain contains entities, value objects, and business rules. Infrastructure contains Entity Framework Core, pgvector, OLAMA, and file parsing. The most important rule is dependency direction. The domain must not know infrastructure. This makes the core easier to test and easier to protect from technical changes. This is the integration slide. DDD gives us concepts such as entities and value objects, and Clean Architecture tells us that those concepts belong in the domain. A business use case belongs in application. Ports or contracts are application interfaces. Technical adapters such as OLAMA embedding service or pgvector search service belong in infrastructure. This is the message for juniors. These are not two competing architectures. They complement each other. Here, I apply the layers to the rack flow. The API receives the HTTP request and validates input. The application layer coordinates the Ask Curriculum question use case. The domain provides the concepts and rules. Infrastructure implements the real connections to OLAMA, PostgreSQL, pgvector, file storage, and text parsing. The separation keeps the project professional and easier to evolve. This slide reinforces the corrected dependency rule. A common mistake is letting the application or domain call the database or OLAMA directly. In a clean design, external systems are connected from infrastructure. Application depends on interfaces, and infrastructure implements those interfaces. This makes it possible to test the use case with mocks or fakes, and to replace OLAMA later with another provider. This slide gives students a concrete project map. I would recommend explaining the intent of each project first, before creating all the classes. Domain contains the core model. Application contains the use cases and interfaces. Infrastructure contains implementations and technical adapters. API exposes endpoints and configuration. This helps the students understand the why before they start copying folders and classes. I close the chapter with the final message. DDD models the heart of the solution, and Clean Architecture protects that heart from technical details. In the chatbot, this means the domain and use case are not polluted by OLAMA, PostgreSQL, pgvector or PDF parsing. The result is a maintainable API that can evolve and change providers without destroying the core design. Thanks for watching. In this demo, we built a CV chatbot powered by generative AI using ASP.NET, Core Web API, OLAMA, RAG, PostgreSQL with pgvector, and Clean Architecture. See you devs! Have a nice day!